Finding solutions in an interval for a trigonometric equation with a squared function. Problem type 1. Here we are looking to find all solutions with x in the interval from 0 to 2 pi, right? All solutions in an interval for an equation that involves something being squared. Maybe something like 4 times the sine squared of x minus 1 is equal to 0. There are a couple of ways you can approach this problem. I think that it is the most obvious to see what's happening by starting with a u substitution. Let's let u equal sine squared of x, so that I get 4u squared. I'm sorry, u is not sine squared of x, u is sine of x, because sine squared of x is going to be u squared. 4u squared minus 1 is equal to 0. Solving this equation for u, I get that u is plus or minus 1/2. But of course, u is sine of x, so that means that sine of x is plus or minus 1/2. In this particular problem, we got symmetric solutions, which makes life easier because if you think back to when we solved the equation with the basic function, we had just say plus 1/2, and we had to stop and think, okay, where is sine positive and where is sine negative? In this case, it doesn't matter because we have the plus branch and we also have the minus branch. So all 4 quadrants work. We just have to determine what is the branch value. Thinking back to the basic angles, theta at 0, pi over 6, pi over 4, pi over 3, and pi over 2. Sine is increasing, so it's root 0 over 2, which is 0, root 1 over 2, which is 1/2, root 2 over 2, root 3 over 2, and root 4 over 2, which is 1. To get 1/2, that means we're looking at a reference angle of pi over 6. And because we are plus or minus, we don't care whether sine is positive or negative, which means there will be solutions in all 4 quadrants. So if I sketch out some coordinate axes, and I sketch out a couple of reference angles, I can start playing around with angle addition to find how this works out. In the first quadrant, x is just alpha, so we get pi over 6 as one solution. In the second quadrant, we're looking at that bit of angle. We know that the angle we're looking for plus the reference angle together get halfway around the circle, and halfway around the circle is an angle of pi. So we have 5 pi over 6. In the third quadrant, I know that x, to get all the way around, is go halfway around and then go a little bit more. So that's pi plus alpha which comes out at 7 pi over 6. And in the fourth quadrant, I barely have enough room on the bottom of the page, but I'm going to fit that in. In the fourth quadrant, we get almost but not all the way around a full circle. X plus the reference angle alpha together forms a full circle, which is 2 pi. And if you solve that for x, you get that x is 11 pi over 6. Right, so in this particular problem, we end up with 4 distinct solutions. And again, in general, just looking at the equation, there are infinitely many solutions. These 4 are the ones that fall in the interval we care about.